Hello, and welcome for joining us this afternoon. I'm Danita Wright-Watson, Program Manager for the Penn State Great Valley Engineering Division, and I am joined by Dr. Raghu Sangwan, Associate Professor and Professor in charge of our Software Engineering program. Dr. Sangwan earned his Bachelor of Science from Haryana Agricultural University, his Master of Science from Indian Agricultural Research Institute, an MS from Westchester University, and a PhD in Computer and Information Science from Temple University. He is the professor in charge of the master's degrees in software engineering at Penn State and is here today to talk about the programs and answer your questions. Without further ado, I'd like to introduce you to Dr. Sangwan.
Okay. Thank you, Danita. So thank you for that kind introduction. Before I get into the details of the programs that we'll be talking about today, so that you can put a face to some of the faculty members that we have teaching in this program, this slide is showing you the faces of those faculty members. They are all highly qualified engineers in their discipline who have worked both in the industry before coming to Penn State to teach in these programs. You can see that they are book authors. So this is only a sampling. There is a lot more than 5 or 6 books that are shown here. They have, authored books. They are fellows of some prestigious societies like the IEEE, which is the premier professional body for engineers around the world, Informs, IETASQ. They're also on the editorial board of many prestigious journals. Like I said, they have a deep experience in the industry, so a lot of them, after coming to Penn State, still hold affiliations with their former employers and have formed new affiliations with the industry in the area. So you can see Siemens, AstraZeneca, IBM, PGM. These are the organizations that they're still actively involved with and working on. So we firmly believe that when students come to Penn State, they should not only get exposed to just the curriculum and take courses here and just leave having taken these courses. We believe that they should immerse themselves in the cutting edge research and innovation in their respective disciplines. So even our teaching is informed by our research. So a lot of our faculty members, and by the way, this is more applied research than basic, applied in the sense that we're looking at real life industry or industrial problems and helping the local industry solve some of these problems. So many of the research aspects that you get exposed to in the classroom and outside the classroom would involve these kinds of problems. So we have several research groups and labs here on our campus. The Big Data Lab, run by Drs. Q, Barben, Nagan, focuses on data science and the application of data science to social media, politics, security, market research, and more. So the idea is taking big data from any of these domains, learning from that data, and then doing some kind of predictive analytics on it. So mostly using AI and machine learning techniques. There's a software and systems engineering group run by Dr. Neil, myself, Dr. Sangwan, Dr. Ergin, Srinivasan, and DeFranco, looking at socio-technical aspects of engineering large and ultra-large scale systems. So as many of you working as software engineers or information scientists know that developing systems is not simply following some kind of a mechanical process. It's a human intensive activity. So how do you make sure the teams work effectively together, especially when projects get large and geographically distributed. Uh, Projects span multiple time zones, and it becomes difficult to coordinate and collaborate efforts across these time zones. So a lot of our research problems are centered around effective team building, coming up with technical ways of coordinating people's work, um, that kind of thing. There's a problem solving research group. So a lot of time um, you would find, even in your own experience, that when people are solving a particular problem, they have their own perspective and how they go about doing it. Some are very out of the box thinkers, very innovative in their way of approaching problems. Others are very systematic and look at a good structural framework around those kinds of problems before solving it. So there's a whole spectrum between this structured way through innovative way of thinking and problem solving research group at Penn State, primarily run by Dr. Catherine Yablokov and Dr. Sally Richmond, um, working in close collaboration with the University of at Purdue and Stanford, looks into this creative aspect of human problem solving. Then we have a whole center here at Penn State dedicated to entrepreneurship. So we're beginning to recognize that the startup culture is not something that should be reserved for, after you've graduated from college and you're looking for work, and then, in the midst of that, you say, well, look, I have some great ideas. Why don't I create a whole new industry around the idea that I have, or create a business or a company around the idea I have. We're thinking that if you have great ideas, while you are getting an education here at Penn State, that we should allow you to leverage those ideas and take them all the way to creating a useful product or service that you can sell in the market. So our Center for Entrepreneurship is an interdisciplinary innovation center, and it includes the state-of-the-art makerspace. So essentially, think of anything you want to manufacture, um, and you have every kind of tool you can fathom available to you to create that product. So some of the things that I remember students have done in that lab is, one time a local township wanted to, um, you know, uh, go through their sewage system to understand the health of that system, if there were any broken pipes or leakages, or did any part of that system need servicing. So obviously it's a dirty job. So they created a robot, right? So the robot could navigate that network of the sewage system, go through it, and give you real-time information as it was navigating through it. So pretty cool stuff. So we do all that kind of research, and these facilities that are available to our students.
Dr. Sangwan, can you tell us about some of the career opportunities that exist in the information science field?
So the information science program at Penn State is designed for many different kinds of positions. So imagine you're looking at an enterprise and you want to make that enterprise better. Where would you begin, right? So the way information science approaches this problem is it says we must be able to initially model how the enterprise works. So we should understand the architecture of the enterprise. What is the architecture of the enterprise? It is what are the different parts of the enterprise, the divisions or departments, and the information that flows across, or the business processes that govern the interaction of these divisions, right? So every enterprise has a particular goal or objective. Some enterprises are in the business of manufacturing products, others providing services. So their goal may be providing service or a product with superior customer satisfaction. So it creates a structure, the enterprise creates a structure to fulfill that objective, right? So that structure includes these departments or divisions and the business processes that govern their interactions to eventually produce that product or service. So when you focus on the enterprise architecture, there's a role of an enterprise architect. So we teach you how do you model a business and its processes and look for efficiencies, right? So when you model a business and its processes, you'll find, hey, there are parts of the business that are too slow and could use some kind of information technology infrastructure to make it more efficient, right? So we teach you in the role of a chief information officer or chief technology officer to look for technologies that can make different units within an enterprise more efficient, right? As a chief information officer or technology officer, you might also think in terms of making all the data within or all the information within the enterprise accessible to anyone within the enterprise so they can use that for some kind of decision making, right? So database technologies, right? So we can also groom you into becoming some kind of a data architect, right? Especially in the age of big data, where whole systems have to be put together, around several terabytes or zettabytes of data. A data architect's role is becoming more and more important, right? So there's that aspect. There's a networking aspect beyond data, right? Accessing data, but then network has to flow that data to where it's needed. It is also the case that flow of information should be secure, right? So chief security officer. So we can groom you into becoming that as well. So there are many different career opportunities that come out of this program. Enterprise architect, chief information officer, chief technology officer, chief security officer, data architect, to name a few.
Thank you. That's helpful.
As you saw on the previous slide, that the information science program has 33 credits, 21 of which are part of the core. And what you see here is that core of the program. So you see the 6 courses here that make up 18 credits of that 21. I'll be talking about the other 3 in a minute. But if you look at these 6 courses, they pretty much align with what the kinds of career opportunities I was talking about, right? How do you build the architecture of the enterprise, right? How do you, so business process management, for example, right? What is my business? What are the processes that govern interactions across all the divisions, all that, right? So that's business process management. How can I make my enterprise more efficient? Information systems architecture. So where is the need for introducing technology? How would I introduce that technology? How is that technology going to access data, database design? How am I going to secure it, IT security? Well, the data needs to flow, right? It can't be an island. So how do I network the enterprise to make all of that available? And then data by itself is not useful until it becomes some kind of actionable information or knowledge, right? So data mining gives you that business intelligence to make that data actionable. So that's the core of the program. Then, of course, beyond the 21 credits of core, 18 of which I showed on the previous slide, you have to pick 12 electives. Now you can decide what is your focus. If you relish being an enterprise architect and want to learn more about how to model businesses, how to make businesses more efficient, you can take courses related to that. So this is only a sampling of the electives. So you can see business process modeling and management. There are, of course, other related courses. If you love data, there are courses on data. If you love security, there are courses on security and so on and so forth, right? So you'll be picking up 4 electives, and a lot of time people just say, I love security and I just only want to take my electives in security area. They do that. Some people love data. They just focus on data. Some people love, business intelligence. So they look more for data analytics type of courses, data mining, or predictive analytics, or data visualization, those kinds of things, right? So those are the electives. So this is the remaining 3 credits of the core that I mentioned 2 slides ago. The information science capstone is sort of a culminating experience for this program. So the kind of stuff you'll see in this course is something that resembles a CIO training. So the idea being, hey, here's a business. It is currently facing this kind of a situation or a problem. How might you leverage existing technology to solve that problem, right? So what you would be given lots of these kinds of business cases, and you may have to go out, review current IT literature to find out relevant technologies, relevant information systems architecture that can use that technology in creating IT systems that can solve that problem, right? So you take this nearly at the end of your program, at least after having a good chunk of the program under your belt.
Dr. Sangwan, can you tell us how a master's degree in software engineering can help advance one's career?
Software engineering degree is for people who are either currently programmers or software engineers. Maybe you got your undergrad degree and in computer science or related discipline, and you started working in an organization. Very quickly you realize that the kinds of systems you build are no longer standalone systems. They are they're large systems that span machine and network boundaries, so they're highly distributed. And many people are involved in the development of such systems. So typically, 20 to 30 people or even hundreds of people, right? So in my own experience, I've worked at both end of the spectrum, but I recognize when you have more than a handful of people working on a project, then how you build a system, you need a different kind of thinking. You no longer are just limited to, hey, do you know the programming language and can you write programs in that language? You have to think beyond that. So what software engineering discipline is meant to do is give you the skill set to lead the development of large-scale software systems, right? So as somebody who's a practicing programmer or software engineer, you come into this master's program and we prepare you for the role of a chief architect, a chief technology officer, or a lead designer, or even somebody who could manage such projects. So a project manager, for example. So why do you need this program for these kind of leadership positions? Well, when programs get large, you will find that it becomes very critical how you design such systems. So functionality all of a sudden takes a backseat. So if someone were to ask you, if I give you 2 equivalent systems, so most of you are familiar with ATM machines, for example, and if I say to you, well, if I give you 2 equivalent ATM machines, they're both functionally equivalent in the sense that you can withdraw money, deposit money, print account balance, those kinds of things. So both of them will do the same job for you. Why might you prefer one over the other? So if you take a moment to think about it and jot down your thoughts, you might say, well, I prefer one over the other because it's easy to use. Maybe I prefer one over the other because it's more reliable. I have more confidence that it's going to properly execute the transaction. I may prefer one over the other because it's more secure. If I'm a banking institution or financial institution, I might say, well, I'm going to prefer one over the other if it's easy to maintain or it costs less. So notice I've nowhere in these descriptions have I mentioned any functionality. Nobody said, oh, I'm going to use one or the other because I can withdraw money, right? Because both can do that. So how one system delivers, or the quality with which one system delivers a particular functionality makes all the difference, right? What governs that quality? How do you achieve that quality within the system? Well, that's the purview of software engineering, right? We teach you how to architect large systems to achieve these qualities. Um, by the way, it's not easy because qualities conflict with each other. You know, the moment I say I want the system to perform, well, but I also want it to be secure, any security measures that I'm going to introduce in the system is going to make it a little slower, right? So the performance is going to suffer. That's why design and architecture becomes challenging. So we teach you that in this particular curriculum, so you can become either a chief architect who can lead the development of such systems. You'll be making those big decisions. How do I create the system to achieve these qualities? Or a lead designer, you may pick up a subsystem, part of this big system, and lead the design of it. You may become a project manager who knows how to achieve the coordination among the various team members that may be geographically distributed across several time zones working on such projects. So those kinds of things. So those are some of the examples of career opportunities available in this discipline.
Thank you for explaining that.
Mm-hmm. So it's a 36 credit program, and 21 credits of that program are in the core. We're listing 5 of these here. I'll mention the other 2 in a minute. So you can see, I mentioned to you, when systems become large, architecture and design become very critical, right? Because it's not the functionality that is important anymore. Functionality is important, but even more important is how do you deliver that functionality with a desired quality. So software design and architecture and software system design, these are 2 courses that focus on those aspects. How do you manage the development of such large system? Technical project management focuses on that aspect. These other 2 courses, construction and testing. Well, software construction is probably one of the first courses you'll take. It's sort of rather than taking a deep dive, it is a broad brush exposure to different aspects of developing large systems. So you can appreciate what you're going to learn in the remainder of the program. It teaches you maybe to put together a decent size distributed systems, and putting it together, you learn why architecture is important, why design is important, why testing is important, right? So that testing is another aspect mentioned here. Those kinds of things. So it kind of walks you through takes a broad brush of things. Software testing, why testing is important. You must have heard, there's never a bug-free system, right? It's virtually impossible. You put even a small system that is a few hundred lines of code, and the permutation and just the combinatorial explosion of how many ways in which you can execute that program makes it impossible to test all of those possibilities, right? So there are, you'll find classic examples if you paid attention where people show, hey, here's a 100-line piece of system. How many ways can you execute it, and how many tests do you need in order to make sure everything is working correctly? How long is it going to take? And it turns out it'll take you eternity to run through all those tests, right? So software testing gives you ways of strategically testing those aspects of the system that are the most riskiest. right? And therefore reducing a voluminous set of tests that would exhaustively test this system to a smaller subset that probabilistically gives you a high degree of confidence that you have built the right system, right? So the course that's a couple of courses that are missing here from the core are the requirements engineering, right? So the first and foremost question always on your mind is, why am I building a particular system, right? So requirements engineering lets you establish what the purpose of the system is. That's important because a lot of times, if you don't do that due diligence, you end up creating systems that are not the right system. Many projects have failed because engineers were given just you know, a simple direction. Hey, build a system for this particular purpose. Never quite getting the requirements right. They thought they knew what they were supposed to build, only to find out that that was not the right system. So requirements engineering is the other core, and then I will little ways down talk about the capstone, which is the other part of the core. Uh, so elective, this is just a sampling of elective courses, but and you see requirements engineering actually spilled over to the slide. It actually belongs to the core, but you can see here many different electives that you can choose from if you're somebody who aspires to become a chief architect. You want to be the point person who drives the development of a large complex system, then you probably want to stay in the architecture and design space. So you would see, you know, on this slide, courses that may give you more exposure to managing and the development of such, or driving the development of such systems, right? Interface design and development, web-based systems, service-oriented architecture, enterprise system development. These are the kinds of courses that give you that expertise. You want to manage projects more than be the technical point person who's driving the design and creation of that system. Well, there are courses for that focus on project management, right? You want to be a lead designer, then probably like the chief architect, you may want to take some of these design focused courses. You want to be a data architect. So data is becoming more and more important. And machine learning and artificial intelligence techniques are being used on that data for doing a lot of predictive analytics or creating intelligent systems. So there is an interest in the software engineering community to develop the skill set for building such intelligent systems. So we do have, if you simply want to be a data architect, meaning you want to focus on that aspect of the system development that worries about how the data is structured, how it is accessed in a very, very efficient way, then you can focus on that side of the thing. If you want to go a step further, you don't only want to be a data architect, but also want to help develop systems around data, then you can take a lot of data analytics, AI, and machine learning type of courses. So that's for architects and designers and project managers. The the other career path that you may focus on is maybe you want to create expertise just in one of the many qualities that we worry about when we build systems. So security is one such important quality. So you know, how do engineers secure systems? So that could be another possibility. So those are some of the examples of the electives. The capstone. Well, software engineering capstone gives you two options. There's the practicum option and there's a research paper option. So oftentimes we find students in the program who say, well, look, I don't want to take the practicum option because it involves simply demonstrating all that I've learned in the program by building an end-to-end system, that takes maybe a problem, solves a problem by building a system, or a working application. So basically from concept to deployment, because I don't want to do that because I've done all of this already, and I appreciate all of the stuff I've learned, so I can do that better. I understand that. I am interested more in taking a deep dive in a particular technology or particular you know way of architecting systems, things of that nature. So the research paper gives you that opportunity. So someone might come in and say, well, look, um, we know we're building intelligent systems, but what are the approaches for making these systems more resilient? How do you even go about testing these systems? Because they are continuously learning and adapting. What are you testing for? So that becomes a challenge, right? So you want to get a good grasp on, are there cutting edge is there cutting edge research that offers you guidance in how to manage the development of intelligent systems? So you might do a research paper on that. You may say, hey, I've heard of this distributed ledger technology, blockchain. I hear a lot of buzz around this technology. Is it going to be good for my organization? Can I do a capstone in that, right? So you're taking deeper dive within a very focused or narrow area of software engineering because you love it and you want to understand it better. So that's the other opportunity. So I think I'll now turn it over to Danita and answer any questions towards the end if you have any.
Thank you, Dr. Sangwan. So by now you might be wondering, what is the next step? So for more information on our information science or software engineering programs, we encourage you to visit greatvalley.psu.edu. If you're interested in starting your application, you may apply online at gradschool.psu.edu/apply. If you have any questions, any further questions, please feel free to send them to us now, or you can send them to me at drw115@psu.edu. You may be wondering about the application process. It's entirely an online process. You would want to upload a current resume, as much detail as possible. You'll want to attach a statement of intent where you discuss your career goal and what it is that you want to accomplish with your master's degree. We ask for you to upload official copies of your transcripts for any schools that you've attended. And then lastly would be your recommendation. We don't ask for a letter, but we ask that you provide the contact information, specifically the email address of someone who knows you professionally. This could be a manager, a supervisor, director, VP, something along those lines, someone that can account to your ability to complete this program. So you would send us their email address and we would send him or her a form that would be completed on your behalf and returned to us. So that is what's required to apply. Please note that the GRE or GMAT is not a requirement for admission into either program. So at this time, we'll pause to allow for you to compile any questions you have. Okay, we have a question. Dr. Sangwan, can you explain to us the backgrounds that you see students have when they apply to either program?
So typically, um, for the information science program, we find people who have an information science or information technology undergraduate background. Um, when they don't have that sort of a background, it is the case that they may have taken some computer science courses as a part of their degree and pursued a career. So we not only look at their transcript to make sure that they are from a relevant field, but we also look at what kind of work they are doing at the moment. So don't hesitate if your degree, let's say, is in something like psychology, but you took a few computer science courses, became interested in pursuing a career in IT, and started working on networks or data, and have several years of experience working in the IT field. So that would complement your credentials well. So we see some applications like that as well, right? So either you have a degree from related discipline, or you have a career in that discipline. For software engineering, we see a lot of students from many different engineering disciplines. So we see electrical engineers, nuclear engineers, chemical engineers, biomedical engineers, um, that have taken some computer science courses and found that when they started working in the industry, a lot of their work involved software, working with software, right? Most of the systems that we see around us today are software intensive. So whether it's a nuclear power plant that you're controlling, or whether it's a jet plane that you're flying, you name any device or product, it has guaranteed, it has some software in it, and many of these complex systems have a large chunk of software. So a lot of our students from these other engineering disciplines find themselves exposed to developing software, and soon they find that it's not a matter of just knowing a programming language that for which they may have taken a course during their undergrad years. They need more. They need to learn what's a systematic way of developing large systems. So that's when they come to our program. So traditional engineering disciplines, we also find people from computer science background. They come in as well. Again, the same problem. They know data structures, algorithms, programming language really well, but they lack the expertise to build large systems and coordinate the efforts of large teams working on such systems. We also get students who have information science and technology degrees. Having completed those degrees, again, they end up mostly developing systems, and they lack the requisite skills for that. Beyond that, sometimes we find people, again, and these are students who maybe many years ago completed their undergrad degree in maybe a discipline like, English or psychology or something like that, but ended up taking a course or two in computing, and then ended up pursuing a career in computing. So now they have many years of experience. We also consider those, although for this software engineering program, we find very few applications like that, but we do entertain those kinds of applications. The other thing I find is when people submit their credentials, on an average, the applications submitted to us have, or their undergrad degree people have completed, the average GPA for these students is around 3.0 or higher. Right? So sometimes it's you want to get into the program. You say, well, I'm an excellent engineer. I've been working for 5 to 7 or more years, but during my undergrad years, for whatever reason, I didn't do so well. So in those cases, I encourage to strengthen your application, um, providing a strong recommendation from your supervisor or somebody who knows how good you are, combined with maybe taking a GRE. We don't require a GRE, like Danita had mentioned, but if your academic credentials are rather weak, a strong GRE score can compensate for it, as can a strong sort of career path with a strong recommendation.
Thank you, Dr. Sangwan. Let's allow a few more seconds for anyone else that might have questions. Dr. Sangwan, can you tell us how often do classes meet for either program?
So we actually, most schools have semester systems, but we have a quarter system. So we have intentionally split our semester into 2 quarters, allowing students to take a course in each quarter. It doesn't mean you can take more than 1 course in each quarter, but likely, in the interest of work-life balance, you would not want to take more than 1 course. So we intentionally said, rather than having 2 courses running concurrently, let's have you just stay focused and not compromise the quality of your work and your life. And every 7 weeks, you just focus on completing 1 course. Right? So if you're taking a 3-credit course every quarter, then you'll have to meet twice a week for 7 weeks. Now, sometimes we have found that it's challenging for our students to come down to the campus twice a week. They only want to be here once a week. So our courses have evolved over the years. Now, not every course is going to allow you that, but many of our courses are now offered in a hybrid format. So you come here for 1 meeting face-to-face. So you get to know your instructor, you get to spend time that day going through the material and resolving any confusion or questions you may have about any aspect of the course. But for the other meeting, most of the material is then placed online. So we have an online learning management system that most of our students use for submitting their assignments, working on projects with teams, communicating with the instructor and with their teams. So that learning management system also is used to then house the material that will be used by the student for that second meeting that they would have otherwise had, would it not have been a hybrid course, right? So if it's a course that's not hybrid, 2 meetings a week. If it is hybrid, then 1 meeting a week, right? So beyond that, sometimes it so happens that you get assigned on a project for which you have to travel and you can't be here for a prolonged duration. Under those circumstances, we also allow you to take not a whole lot, but on a case-by-cases, couple of fully online courses. Okay, so you have all 3 types of courses available: fully residential, hybrid, or completely online. So what you'll find is the classes that you'll take are going to be mostly a mix of residential and hybrid, with maybe a sputtering of completely online.
Thank you, Dr. Sangwan. That appears to be all of our questions for today. So at this time, I do want to say if there are remaining questions that maybe you just didn't want to ask at this time, feel free to send them to me. Again, my email address is on the screen, drw115@psu.edu. I'll be more than glad to answer any remaining questions, or I can share some of the more technical questions with Dr. Sangwan, and I can get back to you with the response. So I'd like to thank you for joining us today, and thank you for your time, Dr. Sangwan.
Well, thank you for allowing me this opportunity, Danita.
Thank you. And again, thank you for joining us, and you all enjoy the rest of your day. Goodbye.